So 0 equals, and you get a quadratic equation here, 9 plus 6 is 15. And no, this one is 51 V2. So 15 V2 squared minus 54 V2. And then 81 minus the, and then multiply that by 2, that's 81 minus 42, which is 39, right? So solve that equation. Again, you should get two answers. One of them should be equal to 1, which means that this should be factorable. If you know that one of them is going to be 1, you can actually factor it like this. Right? If you know one of the answers is 1, you can go, well, one of them is like this. The other one needs to be equal to, right? Feed 2 times that is negative 39. Negative 15 is negative 54. Okay? So that's another way of doing this. If you know one of the answers. Okay, so V2 is 39 over 15, which is 2 and that's 2.6. And V1 will then be 9 minus, let's do that here. 9 minus 3 times 2.6 over 2. It's 7.8. That's 1.2 over 2.6, right? Is that right? Some of these things I'm doing with the brain rather than the calculator, because otherwise your brain gets atrophied, you know? You just use calculator. There comes a point where someone asks you, what's 1 plus 2? And then you just go, forget it, 1 plus 2. So sometimes you got to do this with your brain, So, okay, so now let's compare. One is 2 blocks, same mass, same everything. One is a sphere and a cylinder. So let's see if we can make sense out of this. V2 is 2.6. With the cylinder, V2 is 2.07. The other one, V1 is 0.6. The other one is 1.44. Can we see why? So when this collides with that, let's summarize it here. When that collides with that, the 2 kilogram goes at 1.44. This one goes at 2.07. Whereas when that collides with that, the 2 kilogram goes at 0.6. Oh wow, it really slows down. The 3 kilogram goes at 2.6. So when rolling objects hit each other, the incoming object doesn't slow down as much as if it's just the block. And it doesn't give this one as much a kick as this guy gives this guy more kick. Can we see why? Why? I mean, is that making sense? I wanted to compare them and see kind of if we can understand what's going on here. Could it perhaps be one of the reasons? Could it perhaps be what I was saying earlier? Remember what I was saying earlier is that right at the moment that they collide, this thing is hitting that thing, right? If they're different sizes, it's hitting it at an angle, right? What is friction doing to this guy right at that moment? Friction says, oh no, this guy is getting a forward bump. So let me balance that. Friction applies a force this way. So what is the friction doing to this? It's kind of slowing it. If it was just a block on ice, no friction, then there would be no slowing process. So just when this guy gives it a kick, friction says, no, I don't want you to give it a kick. So it kind of slows it down. So instead of going 2.6, it goes 2.07. So opposite thing happens here. This guy gives this guy a kick to try to slow it down. Friction says, no, don't slow it down. Friction is this way. Now the torque that this guy exerts is this way, you see? So it makes this thing spin faster, and then the torque that this guy exerts is this way. It makes this thing spin this way. And let's see. And the two torques are not equal to each other necessarily, because this R is different than this R. You see, one is that into the board, one is out of the board. So the torques causes the angular momentum of the system to change. However, my point was that the Fs here kind of slows this down and kind of speeds this up. So this is faster than it would have been for a block, and this is slower than it would have been. The other way to explain it, not less scientific way, is to almost think of it as like this. When you have two rolling objects hitting each other, the fact that they're rolling causes their interaction to be less. They're kind of like rolling along and they bump each other, so they don't realize that bump as much as if they were going straight, you know. So the rolling motion softens the collision. That's the way to say it, okay? The fact that they're rolling softens the collision. Okay, with that, let's